Hello, in this two parts crash course we will talk how to leverage Internet of Things and hardware in the loop for SysML simulation. We'll actually demonstrate capability library of Catia Magic to connect to Internet of Things devices, protocol actually to read the data and write the data. We can read multiple data streams and write to multiple data streams, and that could be hardware, could be public internet content. At the end of this presentation you will get the link to download this library and sample project, so you can even today run that, and out of the box it will work with public data, and you can actually publish and read your own data from internet or private servers. We are presenting demo at the beginning, so reading sensor data and SysML simulation, so that will be from the hardware. Then reading public weather data, you don't need to do anything for that, just run simulation, change the topic what you want to read, and you get the public weather station data or any other public data, like for example ISS, International Space Station data from the servers, and how to publish data. And then we will cover also today why we do it and how we do it, so value and technology. In part 2 we will show step by step how to set up the hardware, where to get the hardware, as one example of the controller, and you will learn how to program it to run on your in your environment with your Wi-Fi and so on. This will be like step by step. And then part 2 also will cover simulation in the loop with that hardware, so how we'll run together. With that, let's go to the demo.
Hello, today we will show how Internet of Things communication can be used together with the SysML tool Catia Magic. Here we have library for MQTT protocol, so we can connect, open connection, we can publish something, and we can subscribe to topic. And here you can see simple model which allows us to choose the topic and allows to read the value and even check the requirement. Here if we will go to the behavior, we see that we are using this behavior for the connection. I can delete it here. Yes, delete, so I can move another one from the library here to connect to the server. So here you can go and change the server. You can change through the parameters, so you can change here testmosquito.org, this mosquito.org server name, and then we are reading topic from the block, and we are adding this topic again automatically to this publish, to this subscribe behavior. So you see we can use this one, we can just delete this one and actually add this one here. So that's how easy to use this library to connect to the MQTT server. And now we are reading data from the server, so I just just clicked, and so who is sending the data? So actually the data is sent by this hardware device. So you can see here it does not connect to anything, just use this IP for the topic. And if I click on the temperature sensor, you see temperature is increasing, and I see here it is increasing, right? So I can put it here. Let's see here. See, I can hold it. Temperature increasing, and now temperature goes down. And I can monitor the same using MQTT connection monitor software, MQTT Explorer, open source software. You can connect and see this this topic, same as here you see topic, right? And I can monitor, I can again do that
Now let's show how to extend our simulation with the public data, let's say weather data. And we can find the data online, for example, using again the same test server. We will connect to all the topics, so we'll see everyone who's publishing there. Let's connect, and you see here we have a lot of data coming, so we can search for data, weather stations, and let's see, weather station. So here we have this weather station data. If I will just look for the weather, I would see much more, and I can track, for example, I can track this data, right? I see the history of the data changing. I can see humidity, and I can actually take that same topic. Someone is publishing there, right? I don't know who is doing that, or I might know, right? Because this server we might use together, or any other server. Now I'm coming here, updating the topic. As you see, there is no space between slash, right? Changing the requirements that it should be between Celsius, so yeah, so it will be 25 and 30, and then running. See, now I get the data, and this data is actually coming here from this value. See, I can subscribe to any other data, like for example temperature or humidity, and I can subscribe to multiple actually topics at once and track all of them here. All of that is getting through this cycle, updating this property. I can have multiple cycles, multiple swim lanes or separate blocks with the activities.
Now we can publish something to another topic. So here we have simple sample how to publish, and again we need to connect to the server, and here it's publishing. So publishing is really straightforward. We just use the publish behavior. As you can see here, we delay in order to wait for the connection, we publish, and then we read. So for publishing, as you can see here, we have some sample which is actually just getting this into the publish topic content, and provides the value as a publish. So here we have this one, it comes from here. You see we have here topic, again topic will be coming here, and then publishing random number plus increase by 1, and that's it, you know. And here we have you see topic in this case with the slash, so we can have the topic structure in MQTT protocol. So for example, we can have SP, for example, this is my in general published data, and then I can say okay, home, and then slash my 1 2 3, like my laptop something, or so you can have like structured data to publish to that. So it's 3 levels deep, and then I can publish. So now let's see how it works. So okay, I'm publishing, and you see it's waiting, and then it's actually running as fast as it can, because this one is delaying just by 10 milliseconds, right? So I can slow down a little bit, right? And then here in this tracker, I can see the results. Let's disconnect and let's check that I'm tracking this. SP, no, this one is not correct. Okay, SP, home, and then my 1 2 3, and this is the one which I was updating, right? Back, connect, and now should get the value. So we see the data is coming. Let's speed up, and you see here I got already the data. So I can here in this tool see how the data is coming. this one is here, so just add this information here. So I see this is the one, this is the temperature, right? And you see the structure based on this. And then I can speed up, you know, I can speed up quite seriously. Let's do that. Let's increase the speed of this by removing animation. So okay, you see how fast this number is increasing. And let's do even more, because now we'll switch off animation when the diagram is not active, so this like same as silent animation, and see here the data is coming. So really great speed of communication going through public MQTT org server, test MQTT org server, which you can use for your needs. Now let's go back to the slides and then see how we can actually program the hardware to control any IoT device, Internet of Things device, and how to communicate with Catia Magic for the data gathering and verification, validation.
And now let's talk about value. So as you know, there is traditional V, engineering V, system engineering V, when we go from the validation, from the user needs, transition to alternative and optimal solution architecture, system requirements, and then solution architecture, then transition to the design, implementation, and then unit test, component verification, system verification, and then system validation based on the user needs. So what we achieve here is actually speed up. So we achieve faster verification, faster validation due to faster changes coming to the prototype of the system. So you can expect that system will work just based on the design, but actually if you put hardware in the loop, prototype of the hardware, not all the possibilities, but just one of the prototypes, you immediately test many different scenarios. On top of that, you can do changes quickly, update the hardware code and actual hardware, and do verification and validation, so user expectance and system requirements verification. So that process becomes very fast. Now, what are the benefits using digital tools for hardware-in-the-loop testing? So exploitation of operational limits in a safe environment, identification of failures earlier, rapid verification of project requirements, reduce project costs, reduce product development cycle, data gathering for optimization. As you know, for example, aircraft engines providers, they gather IoT data, gather telemetry data in order to identify early failures, possibilities to fail, and prevent that. And a big part of that also is education, because when we see actual systems, we know that system engineering works. Without seeing actual system, it is hard to know the system engineering decisions, because there is design in the loop, which is in between actual system and the system engineering. So this is shortened the cycle. From the technology perspective, we are leveraging MQTT protocol, which is lightweight publish subscribe machine-to-machine network protocol for message queuing service. And this protocol is implemented in Catia Magic library. So publish, actually connect, then subscribe to receive the data, publish to send the data, and disconnect if you want to disconnect. Then we are using open source Mosquito server. You can use it for your network and your private server. You can use public server, as you saw in the demo, for the communication. Then here we are not showing, but in the future we'll show how to leverage Node-RED, this low-code browse-based flow-driven programming tool, to wiring together hardware devices, APIs, and online services. It has like 4,000 or so connectors, so we can actually connect to anything and then get the data in and out using this tool. Again, open source. Then we are using libraries, which you get as a part of this tutorial. And also we are using hardware, which you will see in the part 2, which is ESP32 based with Wi-Fi hardware with LCD screen and Bluetooth. And this hardware is actually leveraged to communicate directly with Wi-Fi with the selected MQTT server, where you can send data and read data without anyone in between. Last but not least, so how MQTT works. So this is very simple, lightweight protocol to communicate. As you can see, hardware and software can publish to subscribe topics. They select the server, then select the topic, and they subscribe. And no, actually they don't subscribe, they publish to that topic. So then whoever is subscribed, for example, Catia Magic subscribed to that topic, as you saw in the demo, we get this published data like temperature. And then someone else can also subscribe to the same topic, they will also get the data. And database also can subscribe to the topic and get the data. So now if we want to publish something, so we just publish to specific topic, and whoever is subscribed to that topic, we get the data. So now again, same here. This is like protocol, right? So we connect, client A connects, opens connection, right? So we connect to the server, broker is representing MQTT server, and someone is publishing, client B is publishing. Now if we subscribe to the same topic, you see temperature roof topic, we get published data, and we can publish. And if someone is to different topic, you see floor, right? No one gets that. But if someone again published to that roof topic, again we receive the data because we already subscribed to that roof. So as you see, this is very convenient to monitor like solar energy consumption and other type of remote services, weather services. And this is not the only protocol we choose, but it is open source, it is lightweight, and we can leverage it with the quality of service with the secure environments too. Other protocols would be, for example, DDS, OMG which we are also providers. So that would be end of part 1. I just wanted to share that this was initially presented as a tutorial, hands-on tutorial at MBSE Symposium, where we distributed all the hardware. As you can see, controllers to our participants, and my colleagues Cristiano Monteiro and Marco Azevedo was delivering this or preparing this tutorial together with me. And we are looking forward for other opportunities to deliver this tutorial, and likely you will get the opportunity to attend. Now let's see you in part 2, and please check the community post with the data libraries and sample projects.